All right. Welcome. Welcome to the stream. I am Agent Ultra, and I do programming. I like programming. And on the stream, I've been working on for a little bit of while, the past little while, a mud server. We're trying to build a mud server in Haskell. What is a mud? It is a multi-user dungeon. It is a multiplayer real-time game, kind of like the precursor to massively multiplayer online games back in the day, but it's text-based. So you have a little character in there, kind of like D&D. You type in your commands. Your character does what you command it to do, and you play games. The world reacts. Other people see what you're doing. All that kind of good stuff. It's also the last stream of the year that I'll be doing. So, hooray, last one. Because it's going to be a new year soon, and then we'll see what the new year brings. So stream will also be a little bit of a reflection on some of the projects we've done on this stream as well in the past, and all of that good stuff. So, yeah, why don't we just like dig into Bakamud? We'll just see where things go from here. You never know. Because chat, you know, sometimes you show up and things are just awesome. Okay, Bakamud. Where were we with Bakamud? Bakamud is what I'm calling the mud project. It's, last week we were working on room definitions, getting those rooms loaded into the server so that we can start up the server and get all that working. Well, the map, at least, to be able to load the map. So the map is going to be made up of rooms and exits. That's going to be like the space that the simulation of the game takes place in. And I'm trying to get it to the point where we can connect to the server, which we can already do, but like after we connect to the server, log in and all that stuff, all that jazz. The game programmer's mud code can can attach us to a character and an avatar for us, and we can start interacting with the simulation. I want to get that to a point where we can at least log in to see a room. We can log in attached to a character to see a room, and then we can like iterate from there. You know, we've got like an entity component system going, a little bit of one, the precursor of one, the starting of one. That's kind of like the basis for all of the entities that are going to exist in the simulation. We've got our rooms. I think maybe we were just starting to work on exits. Something like that. Anyways, we'll see where we're at here. Yeah, let's see. That one. Network connection. All right, we were trying to like think of where we were going to stick that connection between, that mapping between the entity and the connection. Like the connection represents like the connected client, that the user, the game player is using to connect to the server. So their socket connection to our server. And I guess I was thinking at the time maybe that we would put like an entity ID on that connection and make it like a direct thing. I'm wondering though if like maybe we should have like a mapping somewhere for it, but we're gonna roll with that now, and if we want to change it later, we can do that. But I feel like we're gonna probably want to do that. I don't know. I always change my mind on things as I go along, you know? Think about these things in the back of my mind, and then boom, data work on it comes, and it's like, okay. So we'll see. For now, what should the next step be? I'm thinking that we need to get the way I want it to kind of work is that as much of the low-level stuff as possible is done in Haskell. So that's like the server itself, all the connection handling, the database and persistence and, you know, communicating, flushing, input and output, all that stuff, right? In Haskell. And the mud code takes care of like the game server. So the game designer is going to be developing all of that stuff. And I'm thinking after like authorization, after authentication happens, and maybe some things with authorization. Maybe authorization will be happening in Haskell as well. But the game simulation and the game code should take over at that point. All right, so once we have the connection, the user's connected, they're authenticated and all of that stuff, then we pass off stuff to the mud code. And the mud code can then like set up the user's entity, the avatar that's going to represent them in the simulation, and call some function to like associate this connection with that entity. Or something like this. Maybe it needs to be a mapping. Maybe we don't need to associate the connection directly, but the reason why I'm thinking that we need to associate it with the connection is because then we need to get the output. And what output is the connection need? It needs to see what the avatar sees in the map, right? So that's what I'm thinking. Yeah. So I'm thinking maybe the mud code should have like a function it can call to set that up. I don't know if we're in the right point in time to be doing that. Actually, no, we are, yeah, right? Because we added the code to load the map data. Compile the rooms. Reads the mud main password to the room, exit definitions, and loads them into the state. We just have load rooms right now. That's fine. We just at least just a room. And that's that. Okay. So I'm gonna run this quickly so you can see if you haven't seen it before or like know what I'm up to. That sort of stuff. Go. Start up the server. I will also start like a mud client. And server, ooh, linker error. That's not right. What happened there? Clean the build? Maybe I left a bug in the code from last week? Oh, man. Maybe I did. This is an unusual error. It's trying to build connection. Oh, there's an error in the connection module. We have need more information. It's an undefined reference, so like it's trying to compile and access a symbol that isn't in there. Is there a circular dependency somewhere? For network to server mono and state. Connection. Network to socket. Simulation entity and Bakamud off. Server habit maybe. Date and connection. That should be fine. Interesting. Check out commit before it. Back compile. Okay, so I did introduce some kind of bug in there. Introduce file path. Just changed the state module, okay. We add simulation space, fine, we commented out that. Sim room's just a map. Pile rooms. Just read file left and right. Doesn't do anything super special. Now it compiles. We get into a bad state somehow? Weird. Okay. Alright, so back to where we were. Double checking. EF1170. Oh, sorry, I'm still checked out at not head. That's why it's still working. What did I do? It is head. Gotta be it. Okay, it's gotta be. Yeah, okay. Weird. Alright. Yeah. So anyways, server running, connecting server. Boom. Welcome to Bakamud. Hello, how's it going? Message of the day. Blah, blah, blah. We should probably, like, return an error, like, I don't understand what you're doing there. But you can register an account. It only registers in memory at the moment because we don't have persistence yet, but we'll get there. Var, so like you can register with it and then you can log in. It's after this point, I want to hand off something. Right? Most mods, after you log in, right? Like some mods will have a character select situation. Right? They'll kind of flop you over and say, okay, you know, here's select what character you want, or go to character generation, or do whatever. So we gotta do something with that there. After maybe like a hook or something. So let's see if we can get let's see if we can put a Haskell function into our Lua interpreter and call that Haskell function from Lua. I'm going to need to do that at some point, so let's figure that out. Let's see how that works. Lua. So yeah, the mud code, the game code that you're going to be writing the game in is going to be in Lua in the system. It's a little embeddable language if you haven't heard of it. Pretty easy to embed into games engines. A lot of game engines use Lua. A lot of programs use it for various things, and we're going to use it too. So let's see. I gotta go in the docs to Lua. I think this Urzat stuff is like the low-level bits of the library. And we got you. User data. Maybe it's Lua.call. Function to put. There we are. A function to push Haskell functions as Lua C functions. Haskell functions are converted into C functions in a two-step process. First, a function pointer to the Haskell function is stored in a Lua user data object. The user data gets a meta table, which I guess that's like a Lua interpreter thing, which allows to invoke the object as a function. The user data also ensures that the function pointer is freed when the object is garbage collected in Lua. In a second step, the user data is then wrapped into a C closure. The wrapping function calls the user data object and implements the error protocol, converting special error values into proper Lua errors. Okay, so here's our example. Triangular. Free C function. Triangular L prime. And Lua to integer. Nth bottom. So we gotta pull stuff off of the stack. Push integer. Sum of 1 to n. Return num results 1. Then we call this hslua push new hs function first. Lua set global. Interesting example. It doesn't use hslua push function. Push hs function. Push editor. New hs function. Maybe that's supposed to be push hs function. L is the state of the interpreter, which we do have. Okay. So let's put this in Bakamud server mud code. Maybe it might be underneath, like directory underneath here or something. I'm just gonna like put some stuff in here. Pre-C function. And so we have to call Lua.call. Where's pre-C function defined? Types, Lua.types. Okay, let's do, what if we do, like hello from Haskell, like a hello world kind of thing? Or maybe like an echo. So we can echo it back to Lua. So we got pre-C function. It's gonna drive me nuts. Echo. I'm gonna call it state. Do. And then we have our functions for popping stuff off the Lua stack. Okay, so I'm going to need to know how to do that to get a string. Stack manipulation. There we go. Pop-set elements from stack, copy, remove them to check stack. So that example looks like maybe it's using an ersatz function. So let's check that. Just a little SQL converts object to string. State. The docs on this are a little. Auxiliary. There's that functions. Yeah. Lua.primary. There we go. Okay, Lua to L string. Converts it to a C string. Okay. So we'll get our S. Got to L string. Oh, sorry. It converts the Lua value to the user. Okay, that's probably not what I want exactly. Oh, okay, because the code's pushing that into the interpreter. Okay. Okay. I get it now, I think. This is the Haskell part. That's pushing the integer onto the stack. I was converting it to a Lua integer. Okay. Or is it converting to Haskell integer? From Lua to Haskell. Okay. And then we push integer onto the stack someone and return number results 1 for some reason. And then we set with string triangular, Lua set global. Oh, okay, maybe. we're going to need null pointer. The C size, the stack index, and that. Okay. Nth bottom. And null pointer. What we get from foreign dot pointer. Stop the server and get GHC ID running. That'll be handy. Okay, put a little hole there. And that's because that comes from Lua primary. Nth bottom. This comes from Lua. There we go. Okay, so we should be able to push that onto the stack then, right? I feel like Lua probably push string. And state probably. And our value. Although we want to like modify the value a little bit so we know it's like crossing the barrier. So like hello from Haskell. It's got to be a C car. It's a C string. Or a string, a C dot string. Might have some helpful functions for us. Okay, we'll pull the C string out so that we can do this. Pull it into a C string first, peak C string. Foreign.c.string. Bop, bop. And then we're going to want to put that back into a C string with the C string length to push the string back on. So I think we have width C string len. I think we need the len, right? Probably. Or C car, yeah, the length as well. Boom. And with C string len, takes our string and gives the callback and IO. So we'll do our string. That way, Lua. Then what do we get? This C string leng. Where's the pointer? Where do we get the pointer? Oh, that has both, doesn't it? Yeah, okay, it's a tuple, it's a type alias. And then we're gonna Lua push L string state C stir and C stir len. Oh, we're gonna convert that to a size. Because if for some reason it gives us an int. Come on. Come on! The foreign function interface libraries in Haskell are actually really, really good, I find. I've done a lot of that this year. When we did the Tiger Beetle client library, I had to bind to a C library, create all the bindings for it. But this seems like a bit of an omission. That should be a C size. Come on. Is it foreign to C types? How can I create a C size? From a word 64. I could maybe do a from integral on that and use the constructor if it's exported. Oh, look at this. Hopefully that'll work just fine. And then we got to return num results, was it? Apparently that's redundant. For some reason that's redundant. So what's that? We just have to import Lua. Okay. Okay. So there's our echo pre-C function. Now we got to load this into the interpreter. Where are we going to do that? Where are we going to do that? Handling the login, the registration, and all that stuff in the server, maybe? That's our definition of the server, monet itself. So command handling and parsing. Client stuff. I'm just gonna find where I import Lua. Component, that's the parser stuff. Space as well. Simulation. This looks like a place. Yep, that's where we get the server state. Open libs. The mud main module. Okay, yeah. We're still trying to do that. Oh, look, I did C-size there before. Ah. That is an omission. I feel like that should be... That could be something that could be fixed. Anyways. Yeah, let's add this function. We have mud code. We could probably do it right here. We're going to do Haskell-Lua push HS function. It's our state, and the pre-C function. Oh, I think we called it. Has to be lift diode. Okay, and set global. Lua set global. Do we lift diode as well, probably? Let's see, deprecation warning. Interesting. Okay, so in the use of Lua set global, imported from Lua but defined in Lua to primary. This is an unsafe function. Errors will lead to a program crash. Consider using Haskell-Lua get global instead. I think I want to set the global, don't I? Maybe I don't even need to. Maybe let's let the examples just like out of date. We probably still do that here, here, yeah. Okay, this code needs to be updated because it's not going to execute any Lua code anymore because we changed main module from like a file to just a file path. So we just have to add the path to it. So I think we get from that, and we'll call it like main.lua. That's from file path. System.file path. Yeah. Okay, that's our main like tick loop here. So for the server tick loop, does all this stuff to like do the tick and stuff like that. So I have some commented code here from before when we were like testing out the Lua interpreter, calling Lua code from Haskell. Now we're going to do the opposite direction. We're going to call Haskell code from Lua. We're going to go create that. Probably created it in Bakamud. Now we call it main.lua. Okay. So we should have an echo command in here now. We can put a Lua string on. And maybe that's all it does. No, let's assign it to a variable and print it. I think it's like that. Okay. Let's run the server. Okay, everything's good there so far. We're not actually calling this yet, so let's go back over to simulation. Just like that. I think that'll just call the whatever's on the top of the stack. No. Although we're not seeing the tick call here either, actually. Which leads me to think that maybe the thread is crashing. Could be. Simulation start. Okay. So I think it's probably crashing, and that means that I want to restructure how we're forking off the simulation process so that if it crashes, the main thread gets notified. Seems like we should fix that. But let's see where it's crashing. Probably in this block, I bet. Trace here. We'll add one here. Maybe we can show the results. Lua is not okay. Okay, so it's not even getting to there. It could be load main. Aha! Probably is failing there. Still, we should have that exception reported to the main thread. But for now, when I added main module like that, shouldn't be this. Should be a here. There we go. That's better. So getting our ticks, accumulate DTs, and all that stuff. So we're going to begin tick and end tick. I'm going to take those out. Run. So accumulate DT is coming here. Oh yeah. Then we should be getting here at some point. Let's trace that out. basically 0, which is not what we want. So get the current time in nanoseconds from the system time nanoseconds divided by 1,000,000 millis. Millisecond. Okay. We get the last time. TVAR. We get the time rate. Accumulated time. Oh, I'll get that. Didn't show the current time. I'll get the last time. And accumulated time. Okay, so we get current time about 665, last time about 665. Sometimes 662, sometimes 663, 659, 667. So like pretty stable there. But if our delta time is one minus the other, then yeah, like 0. Accumulated time is going in negative, a negative number. This is all not right. So we modify accumulated delta time here, taking in the delta time. And we update it by adding delta time to it. So if anything, it should be 0. I mean, it's not changing. So, is it? 659, no. 14, well it is a little bit. Interesting.
I don't think it's appropriate to call them human anymore. They will be something else. Something.
Okay, so we should be subtracting our accumulated time, or how much time has elapsed since last time we looped in through the tick. Current time and last time being the same is kind of not what I was thinking. Even this code would be the case. Why is last time that? Or just reads last time. We set last time to be the current time. Now that should probably be the time stamp. Or we just increment like a tick variable and do it like the old school way. I mean, this is not the most sophisticated loop ever, but you know. Okay. Let's make last time just last time. We read it with current time. Take off the divide by a million. What a moment. Is our time rate? Accumulated time, for some reason, is not the right number we're looking for. Yeah, we want to do current time minus last time, and then we'll add the divide. A million. I don't know what we're going to be using accumulated time for here. So now we're hitting tick like we should be. Okay. So now we hit the tick like we should be, and now I'm going to clean this up a little bit, and then we'll dive back into the Lua calling stuff. Current time, last time, that's fine. I think we're going to have to get rid of accumulated time. Oh, I see what we use a cube time there for. I know that I decluttered things a little bit. So we accumulate the delta time until we get over our time rate. And then we call that one tick. Okay, does that still run? Okay, get rid of the accumulate. And I think we could just get rid of the debug. Fix. Okay, that's good. Okay, I want to take a little pause and just make sure we make a commit. Changed mud code. Added the echo pre-C function. Changed simulation. Yeah, we update the tick there. Stage that one. Modify Bakamud simulation. HS. It's a tick loop. Okay. Okay, so now we got to figure out how to make it actually call the, like, us call the Haskell code, or the Lua code, and the Lua code to do the its thing. To call this script. Make sure it's an actual useful Lua script. Insert error into load. Next pairs p call print. Yeah. IO.write is what we might want. Basic Lua, hello world. Print io.read, print, same diff, I guess. Maybe we're not calling it properly. Haskell-Lua. Load and run. There we go. Supposedly we have loaded the Lua code though. Right? That just loads the code. Then we get the state from there. Main. Oh, okay. Load buffer L co-pointer name. So that's where we Lua L load buffer. This one. Okay. How do I execute or run that script? Oh, okay. Maybe I gotta call it through a function. Maybe that's what I'm gonna do. Function main and do. If that does anything. Nope. I'm gonna bring the debug back. Make sure we're not crashing again. We gotta fix that. Let's see, right about here. So I want to go trace M here, simulation. Loading Lua code. Lua code loaded. Okay. Okay, it's loaded. So then what do I need to do to actually call that? pcall, I'm gonna use pcall. Margs, results, stack index. So to call a function, you must use the following protocol. First, the function call is pushed onto the stack. Then the arguments to the function are pushed in direct order. Finally, you call Lua pcall. N-args is the number of arguments that you pushed onto the stack. Okay, so it looks like I gotta push the function onto the stack first. We were getting this was a lot of, we had this working earlier where we just loaded the module and it just ran the module. Get functions, no. Stack to Haskell, no. Okay, let's see if I can emulate that here. Global. Lua get global. And Lua pcall. L, sorry, our state. Numargs 1. That's a capital A. Num results 0. And num results 1 and stack index 0. And Lua dot. That. And Lua dot be call like that. All of the things. The typo? What's going on here? Name not in scope. Oh, I deleted some code I didn't mean to there, didn't I? Okay. We did discard a status code, didn't we? Use Haskell-Lua get global. And what's this? It wants the state, a C string, a C size. So it doesn't want just with C string len. Should we get the len? Pop that off there. So it wants the C string, then C size, and a pointer. And we'll give it the null pointer. Which we have to get. Round form, that pointer. And good old not actually a size. That's probably going to want the same thing. Okay, so documentation maybe perhaps a little bit out of date. Could use some love. Might be a little holiday project for me. Get that updated. Maybe fix a little bit of this in the core libraries. Sterling. Oh yeah, I need a adult pointer. And the string probably. There we go. Yeah. Ooh. Okay, we should be getting Lua to print something here, unless something funky is going on with Lua's output system. Are we not getting there anymore? Nope, I guess not. Interesting. Status code 3. Error syntax. Okay, we have bad syntax. A syntax error. Okay. Yeah, I'm going to put this in the backlog to definitely fix, because this is getting kind of shonky, and we should know. We should know that this is a syntax error, but we're not checking it right now. We're only checking if it's really not okay. But, like, if we... For some reason, it's swallowing this error and not, like, reporting it to the main thread, so I gotta fix that. And we should just report the main thread, like, whatever the Lua error is. Okay, so let's go to our main. Okay, I don't have a do on there. That's what it is. Meh. Now things are fine. And now we're at calling Lua again. Okay. Okay, so that loads and parses. So, instead of print, I get main, the version or anything like that. We just Lua p call L, no arguments, number results 1. Okay, so we're getting here. What's HS-Lua get global L doing? It's like this function. Okay, so it does push onto the stack. The value of the global name. Okay, we should type that variable. Okay, so that's pushing onto the stack the name main. Maybe it's just 0, expect 0 results. Maybe I should just print. Okay. Does it not exist, maybe? Take out the function main. And we don't HS-Lua get global. We just Lua p call whatever's there. Can I do that? Let's get rid of this. This. Takes time. State equals 0, that's what we want. That's not quite working. Brrr. What is the result of load buffer do? Loads a buffer as a Lua chunk. Uses Lua load to load the chunk in the buffer. Measured by buffer size. This function returns the same results as Lua load. Name is the chunk name used for debug information and error messages. Okay, Lua load. Loads a Lua chunk without running it. There are no errors. Pushes the compiled chunk as Lua function on top of the call stack. Otherwise, it pushes an error message. Okay, so it loads it as a function. And yeah. Loads the chunk without running it. No error, no. Occur. So pushes the compiled chunk as a Lua function on top of the stack. Right, so this should be on the top of the stack, I guess. Our code. Which binds message to our Haskell function echo that we define called echo. What if I could just simplify this? Okay, call hello from Lua, okay. Then we get a seg fault. Let's see. Hey, Chicksor, what's going on, buddy? It is you, the greatest of Chicksors. Welcome to the last stream of the year. How's it hanging? I think we're almost getting to the end. We'll run a little late tonight because it's the last one. Might as well, right? Back from the Gaim. Oh boy. The gym. I like it. Gotta stay healthy. Condition. Strengthen. Better, faster, smarter, harder. Yeah, marathon, eh? That'd be sweet. I used to run endurance races. Not like I haven't done a full marathon, but like off-road endurance races, like 10K or so. So not like crazy stuff, but you'd be running through mud and up mountains and climbing ropes and stuff. I haven't done that since my kids were born, though. Yeah, the Minneapolis one. Cool. That's good luck, man. That's awesome. I would like to hear about that when you do it. When you get across that finish line. But yeah, so just calling into Lua, that's working just fine. We pushed a Haskell function onto Lua's stack, but for some reason we can't call it in Lua. Maybe I gotta give it a better name. Yeah, you did it this fall too? Bravo. Bravo. That's awesome. Yeah, like marathons take a lot out of your body, right? I have some friends who run them, and oof. Yeah, yeah. Well, that's, you know, there's a next time, so that's great. Yeah, I got into sailing this year in the summer, so that's been my kind of new sport. I joined there's like a local club. And so started racing in the racing nights. I'm working on trying to build a mud server. We're trying to learn how to do that. So mud is like a precursor to like modern day MMOs. It's somewhat real time, text-based, multiplayer, like Dungeons and Dragons if you want to think of it that way. But you can make any game you want with it. We're building the engine in Haskell. It's going to be programmed in Lua. So the engine in Haskell just takes care of persistence, networking, concurrency, and all that stuff. And then executing the game code. So I'm just trying to figure out how to get Haskell functions callable from Lua. You should be able to create a function on the Haskell side and then call it from your Lua scripts. Yeah, they're fun, right? And they're pretty straight. I'm making it a little bit more complex than it needs to be. If I was making a very basic one, it'd probably be a lot more simple. But yeah, they're not too hard to get into though. For some reason, I'm segfaulting when I call this Haskell code. All it does is print hello from Lua. And for some reason, it's like, no. You can't do that. Lua pcall. I can Lua pcall I can pcall a Lua function, but I don't know why it's core dumping on me right now. Will it core dump on me if I take out this stuff that I'm messing around with on the stack here? Yes. Okay, so I'm breaking it or somehow by loading this Haskell function. Maybe I gotta do it after the load buffer. Just for this call. I gotta figure out how to structure all this stuff properly. But yeah, I just want to get that code going. See if it'll even work. Okay, so let's plop that down here. And then what did I do? The result wanted to stay. Okay. Okay, I'm gonna do it in a separate block. Let's try that. Mud Rammer. A modern mud client. Okay, cool. So that's the client. I'm building the server. Well, that's cool. So if the server ends up working, I'll test it out with this client, see how that goes. Eventually, like, if this goes, like, pretty well and, like, we can get it running, I think it'd be a fun little thing to, like, have some Twitch integration with it, you know, with the stream and build something, you know, that we can all mess around with. But I'm mainly doing this as, like, a learning exercise, just to, like, mess around with parallel and concurrent programming in Haskell and all that stuff. And to mess around with, like, calling foreign languages from Haskell and, like, binding them and embedding languages in Haskell and stuff. Because there's some ideas and some things I'm curious about there. Okay, so hopefully that works. Okay, segfaulted. Awesome. Okay, so lessons. Got to be super careful calling Lua because it will segfault your stuff. Yeah, don't worry about investing. This is bargain basement code here. Bargain basement Haskell. It's of little use to anybody at the moment. Call me back in like a few months. We'll see. We'll see. Start a new game studio. Okay, yeah, okay, so for some reason Haskell-Lua that's just not liking me. Okay, so what if we just don't load the buffer? Okay. Well, I'll leave this here. What if I can just push the function on stack? Because that was working okay before. But we'll p-call... Can I call that from here? Down here. So I will call our echo function that we defined in Haskell. Put that on the stack. It's got to have arguments that we got to push. One argument. Don't know if I got to do it on the global. How do I push an argument onto the stack Haskell-Lua? Okay, it pushes the zero terminator. So I gotta get a C string, push it onto the push on the stack with Lua push string. Okay. Yeah, we'll do it like that. Lua push string. There. Numargs 1. Results 1. Scataboosh. Oh, I was gonna prefix that because I'm a dummy dumb. I keep forgetting that. Okay, segfault. So maybe it's my implementation of my Haskell function. Maybe it's me. That was defined, by the way, over here. Echo, pre-C function. Yeah, I mean, it's true. In this advent of code, I've been doing it in C, and there was one day where, like, I was like, okay, I need a vector. So I wrote a vector, and my solution didn't work, and I thought, oh man, maybe it's my vector. It's got to be my vector. Nobody can write a vector that works from the start on the first try, right? Like, that's just weird. It wasn't the vector. It was my program. So I fixed it and it worked. And my vector, I've been using that vector for every problem since, and it's been awesome. Wizard powers. Galaxy brain. Okay, well, we're running a little low on time, but yeah, I wonder with C string length, if I'm seg faulting because this, when I push this string onto the stack, like, is Haskell garbage collecting it or some stupid stuff like that? You know what I mean? No, it should be passing a copy, right? How do I push results? Push Haskell functions. Yeah. Right, and then they do this thing here, which I get a deprecation warning on setting globals to make it I guess to make it a global function. But you push integer, right? I'm gonna push string. Just takes a C string. Simplify, simplify, remove code, remove stuff, and ye shall find the way. It's how it goes. Still cordoned. Yeah, I'm finding the docs on this thing, this library in particular, are just a little bit out of date, a little hinky. I mean, ostensibly it works. I just don't know what the hell I'm doing. I'm just trying to figure that out. But also, welcome to the stream system, Carl. How's it going? Okay, what does my 2L string do? Converts the Lua value at the given index to a C string. Okay, so if there's no stack, no, there's nothing in the stack in the right place, maybe that's where it's like seg vaulting on me. Let's ask the Primogen. The Primogen would not appreciate our Haskell-y ways, though. But maybe we could convert him. Docs be docs. Yeah, nobody likes writing them, so... Like, I ostensibly, I kind of like writing them. Do I always write them, though? No. Ostensibly do, but like when I'm packaging my libraries, like I go out of my way to like review. I try my best to review the documentation in the haddocks before I go live with my packages, for sure. Just because like I don't want that experience where somebody copy paste something and it breaks. Checksource says docs are better than code. That's a good take. It's not quite hot, but it's just pretty, it's pretty warm. Yeah, so I guess maybe that's probably something like that. It's like I'm not getting the right value at the stack or something. What if I just simplify this even more? Get rid of all this stuff. And I just put the C string, push it to the stack, num results 1, and just do that. I'm still seg faulting hard. Well, I'm gonna have to figure out this another time. Let's do a little review of some of the stuff I've worked on this stream and look back on 2025. Look back on Haskell and how far it's come this year and some of the cool things that have happened in Haskell land and that sort of stuff. We will just discard these changes another time. Push up what we've been able to do so far. So if you haven't seen the code before, it's your first time tuning in or whatever, I'm Agent Ultra. GitHub.com is where I host my code, at least for now. And this is Bakamud. So you can find it there. I'll paste that in the chat. And let's see. 2025 has been a prolific year for this stream. I did a library, Tiger Beetle HS. Soon to be accepting investment money, yes. Hire me or come to me and let's start a business and take over the world and get some capitalism. Yeah, so I made the community client for Tiger Beetle for Haskell. Tiger Beetle is a financial transaction database. It's a double entry ledger that can be distributed across multiple nodes. It has a pretty decent and interesting resiliency story in that it's really good at failure recovery and all those sorts of things. And so that got put up on Hackage this year. That's pretty good. What else? Replicant, that was a 2024 joint. And I think we did a game this year, didn't I? Tiger Beetle. Disco. Oh, we worked on wave function collapse, that's right. Yeah, I didn't get that finished, unfortunately. That one was challenging. So we were talking about algorithms last week a little bit with Advent of Code and all that. And I got a book to help me like think about algorithms better in Haskell, because it's just a lot of algorithms, like the wave function collapse algorithm, for example, and a lot of algorithms are described in the literature, popular literature, in more popular languages. They kind of assume procedural languages with pointers. And this one, yeah, I struggled to get this one to like go. Like, we review a little bit of the code here. I think it was having problems with termination or something. But boy, I hate this little sidebar. Yeah, so you have to like go into this grid kind of structure, look at the different cells and the neighbors, right? And then do something to your cell, kind of like Game of Life in a way. But you're calculating, you're trying to narrow down results to, you have a stack of all possible cells, values that it could be, and you're trying to narrow it down to one, right? And as you narrow things down, you got to narrow down the neighbors and so on and so forth. So you kind of like flatten out a table of cards. So it's very, very like mutation heavy. And I think if I'm gonna like revisit this and take a second stab at it, I'm gonna have to like figure out either a better data structure that's more functional than arrays, or maybe a better monad for working with it. Something. Yeah. I know we were getting like kind of far with it, but it's quite a bit of code. And I think 800 lines, even with like the way I use line space, still seems like a lot. So there was that. And can I sort these by date? Last updated. Yeah, okay. That's about it. And, well, I tried making a little mastodon. I think that was 2024, yeah. So that was it. Like, wave function collapse. What was disco? I don't remember what disco was. What even? I think I was just messing around. Oh, yeah, no. Disco. This was the assertions library I was, like, messing around with. That assertions paper. I was trying to implement, like, these kind of, like, monadic assertions so you can, like, short-circuit computations and stuff. Sort of like you get with the assert, but different. That was pretty fun. Disco. I didn't make that into a library, though. And the rest is, yeah, other stuff. That's it. 2025. What a year. It's almost over. We've got a little bit of time left. What did I see in the Haskell universe that was neat this year? I think the typable people put out an update on Basil and Buck 2. I think it was Tweeg. Was it Tweeg? Anyways, there was a great talk on that. And it sounds like they made a lot of progress on it, which is great if you have a really large Haskell code base. Certain patterns in large Haskell code bases can have just really bad, not bad, like, I don't know how to say it. Like, Cabal is just not good enough to do it. Nickel from Tweeg. Cheap configuration language. Cool. You know, there's a cool Haskeller that did one too. A configuration language called Doll. Yeah, it's like Doll. Cool. Yeah, so they got that working, which has some knock-on effects from, well, the rest of the Haskell community, I think, with faster builds, and could make Haskell a little bit more appealing to enterprise users. So I remember that being a bit of a, when I was working at Mercury, quite the endeavor. Oh, let's see, Mercury has an open source one. Buck 2 Haskell. Oh, just some definitions and stuff for Basil. But yeah, they got it working. So you can do like very, very fine-grained rebuilds and across multiple packages in a single repository, which is pretty cool. Ugh. Checksor. Doll to Clipper config. Clipper 3D picture configuration using the doll config language. Cool. I don't do any 3D printing, but neat. Project structure. Huh, cool. You want to add a hardware abstraction layer using the config language. Is that so you can like take these configs to like different printers? Is that what you mean? Mm-hmm. Ah, very cool. Very cool. Stepper, pretty printer. Awesome. Band config and all that stuff. Right on. You get a lot of use out of that? Do you do a lot of 3D printing, Checkster? Got a couple of them? Yeah, right on. Cool. Let's see. Combinatorial interview problems with backtracking solutions. From procedural to functional programming. Ah, this might be like an interesting talk that is like the missing link for me here. The State of Haskell Survey. Oh, we're doing it again. Oh, I haven't done it yet. Oh, 4. Wow, okay, cool. Start a little business or something there. Computing the power set of a set. The set of all subsets. Alright, so here's your Python code. Yeah, this looks like an engineer made this, right? Like, so good. And the first thing we did was take that code and translate it to the Scala equivalent. So very procedural looking still. We're going down line by line, if this, then that. I mean, that could be an expression, but still. And then we go to the next line, current subset. So some kind of like... here's the all... nerd. 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 There you go. I'll check that out. We got to do the Haskell state of survey. State of Haskell survey, of course. Ah, Foldzilla is doing Haskell Advent of Code. They finished it. A big part of this has been the Reddit AOC. Here I could look at other developers' approaches and that of more experienced Haskell developers. Continue with the learning experience. I would love to have feedback on one of my recent solutions to AOC, namely day 7 of 2015. Oh, you're going back and doing them? Okay. This is the most recent software I've written, and let's get some. Using bang patterns, deriving any class, generic lambda case. Uh-oh. Uh-oh. Okay, looks like we got a language interpreter here. Circuit and signals. Parser. Love it. Which parsing library are they using? It's not the built-in one, is it? No. There's our evaluator. Alright, pretty straightforward. Very aggressive on the inlines. I bet, you know, some people have like solved these things on like Excel spreadsheets and typewriters and stuff. I wouldn't be surprised if there's some nerd out there who like solved all of the AOC problems on like an HP calculator and put us all to shame with their awesomeness. Although I would be super interested to see that, and I would not be ashamed that I don't know how to do that, but it sounds fun. That would be super funny if somebody managed to do that. You know, I am currently rebuilding a Commodore 64 from like 1983. It's kind of trash. I'm sitting in attics and garages, and it's not looking like it's in good condition. I'm trying to restore it. Maybe next year I'll do AOC on the C64 if I can possibly get that to work, because the inputs might be just too big for that machine. Oh yeah, I have to desolder a bunch of stuff, replace all the electrolytic capacitors, test all the chips to make sure they work, make sure there aren't any broken traces and stuff like that, because there's quite a bit of like rust and stuff on it. Yeah, I'll probably lighten up the case. One of my favorite YouTubers who does restorations has like a really cool process. I'll need some equipment to make it work, but I'd like to try it. The case is like pretty decent, but it needs some lightening. And I'm missing keys. That's the only problem though with this machine that I got. But I have disk drives for it. I've got boxes of disks. I've got old how to program books and teach yourself how to program books using BASIC. So it could be pretty fun. Fun little project. So yeah, I don't know. Foldzilla, your code looks pretty interesting. A lot of inlining stuff. Maybe you got benchmarks or something. And that's why that's all there. And that's cool. Make a Mudfoot client for the company. Yeah. That's a good point, Checksar. That's a good point. I should do that. Arguments for Haskell at scale. Let's go. Deciding on a language to use for a large project is a difficult choice. It's true. Facts. You have to make a business case for whatever tools you use. Other languages besides Haskell have bigger ecosystems and less steep learning curves. Yes. You don't always have to make a business case for it. Sometimes you just do it in the language you want. So most companies, when you start a startup and I'm like, hey, I'm going to start FooBars, I'm going to make software, I'm going to choose the language I use because like it's my day job and what I'm going to do, and I'm risking my neck starting a business on it, so I'm going to choose something that I enjoy, and that will typically be the language for the company in most companies, right? Like if I chose C++, that's it. It's pretty much C++ for the rest of eternity until I decide to like start a different software project and something else. Not always true, but generally. But you don't just have to make a business case. That's one area where you don't have to make a business case. You just choose to use it. Another one is like back 40 projects or like tooling, right? Sometimes you're like, I'm just going to write it in Rust. I'm going to write it in Haskell, whatever. And you just do it. It's not the product. It's not in anybody's way. I just have to maintain it. And if other people find it's useful, that's great. Don't have to justify it. So, does Mud require network? C64 doesn't natively, no, but there are people who've made custom hardware for it to do that. So like, I think even Wi-Fi cards. So it might be possible. Although, fun story, a couple jobs ago, or some jobs ago, there was a project that came down the pipe where I thought Haskell would be a good fit. And we were a JavaScript shop at the time. It was a JavaScript shop I was working at. So like that was the core competency of the company. Everybody there knew JavaScript. Maybe not everybody liked it, but everybody knew it. And that was the language. And this new project came in. Completely new project. Had to be completely developed separately. And I was like, hey, this is kind of an important project. And it was, because it was like supposed to be like regulated. It was a regulated project. We had to like go through a bunch of regulators to like sign off on our workflow process and what technologies we're using and blah, 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 blah. And I was learning Haskell at the time. And I was written some stuff in it. I took some courses. I was doing well. And I was like, hey, this might be the chance to use Haskell. So I made the business case for it. Right? My business case was like, well, gosh, what was it? Like, it was something ridiculous. Like, you know, this is going to be built like once. It's got to be done well. And like, we need to be able to like, we're probably not going to touch it a whole lot once it's in production. And we need to like be able to maintain it in 6 months from now. Haskell's really good for that kind of stuff. Wow, they have ones for, they have retro network cards for the NES as well with online matchmaking. That is so sick. I should look into that. The NES is like, I love that machine. I don't know what it is about that machine, but I just really enjoy it. Yeah, I play Tetris on the NES. Love it. Anyways, made the business case for Haskell. I don't remember off all of the details of like the business case, but I laid out like a whole document. And presented it, you know, to the founders and stuff of the company. It was a small company. And they were like, okay, trust you. Let's make it work. So I was like, okay. And that project didn't turn out very well. And not because Haskell was the problem, but because it got kiboshed, unfortunately, by another engineer at the company at the time who thought Haskell was a risk. So it's not always because Haskell, right? Sometimes it is because people, right? So you can't just come in and like stomp on people and say like, we're going to use Haskell now. But let's see this argument, the rest of this argument here. So beyond this, I have been thinking of one of the non-technical challenges. I just explained one. Here's another. I think many programmers basically believe that all languages are mostly the same. Like, they don't want to program in Visual Basic, and they would be on board with rewriting a legacy COBOL system in a modern language like C#. But C#, Java, Python, TypeScript, etc. are all imperative, object-oriented languages. Because of this, they are inherently somewhat cynical toward language debates. You've got a particular person in mind. Massive squirrel. They weakly favor one language over another for reasons of tooling, ecosystems, or aesthetic qualities like syntax. If you argue to them for one language in particular, you'll see through the lens of sure, but you can build a system in any language. They may understand that you're attracted to the language for subjective reasons that vary from one person to another. Yeah. A lot of people, a lot of programmers I find are like, the first thing they look at when they see a new language is like, ooh, that's some nice syntax. I like that. It's cozy, or it's familiar, or it's pretty. They don't really think about the semantics so much. If you argue passionately for one language in particular, they may walk away thinking you're essentially a religious zealot. And honestly, like that wave of Haskell developers around 2008 or so, if you're one of those people and you're online being like, Haskell's the best. I tried it for like a year and I bounced off of it, and I felt pretty good about bouncing off of it at the time because there were a lot of religious zealots in that space at the time. And so I was able to be like, Haskell zealots. Never again. Until I met someone who was much more humble and convinced me. Representing your own subjective preferences as universal superior qualities of your favorite language. Well, Haskell is the superior. I mean, come on. Galaxy brain, right? And 2, overstating the importance of the language itself relative to tooling, ecosystem programming, market size, etc. Okay. So you don't want to show up and like be like, you know, the big brain Haskell zealot. Okay. So because of this, I often refrain from speaking up at work and making a case for Haskell or any language design with static analysis as a priority. Because if my case is too weak, then I'm worried I'll just get typecast as a functional programming zealot and it will harm my credibility. It's true. You know, I feel you. Cloud scale. Super cloud scale. Like MongoDB's cloud scale. Yeah, so like credibility is one of those funny things, right? Where if you desire it and you really need it, you're going to be very, very worried about having it or losing it, right? And so it's going to influence what kind of things you choose to focus on. And you might not choose the things you like because you're so concerned about your credibility, right? And choosing functional programming languages they're not the most popular right now, let's just say. And so if you care about being popular and having credibility, yeah, I could see that how that could harm you. The other take, though, is that you could not care. Right? Life is too short to like suffer bad ideas. And fools. Mildly. Right? A little bit of foolishness is totally fine. Totally fine. And you're going to find lots of it everywhere you go. But you can stop and say, you know what? Yeah, that's fine. You know? You can go deep on Haskell. Go like deep. It's all good. If it'll make you happy. Many people think of static typing versus dynamic typing as religious war. Nah, it's not that religious. But maybe people probably do think that way, though. It's an article of faith rather than something that could be debated using logical arguments and empirical evidence. Well, the thing is, like, there is empirical evidence, right? Especially if you try, like, have you tried writing Haskell? Yeah, I've tried leading a team from like no typing to using gradual typing tools in JavaScript to like fully typed JavaScript. It's not an easy battle to win. It's uphill. It's like Sisyphean. So in there, that was like way back in the JavaScript shop. And TypeScript was still fairly new. And Flow was still fairly new. And Flow was still competitive-ish with TypeScript. TypeScript hadn't fully won yet. But we were trying to get our stuff typed. But like, the whole premise of gradual typing is that like it's all dynamically typed and you can add little bits of typing as you go along. But if there's one any in your whole graph, one any type which matches any other type, it's useless. There's no safety. And Vito because it's a Microsoft project. Oh, well, I mean, fair, I guess, but... So, like, it was just... Things eventually do get fully typed, like one module, right? But then you're using that module in another bit of code, and, like, that... Using functions from it, and it's got all the types, and it's great, but then you're using some other module that's not typed yet, and it's like... All bets are out. And it was just an uphill battle to get one, developers to add all those type annotations while under pressure to deliver features at the same time, and like manage technical debt. And like we tried different strategies to treat like typing as, or lack of typing as, technical debt and stuff. But it was an uphill battle. It took a lot of effort, and it was just a job that was never done 100% when I was there. By the time I left, we got far, but not far enough. But have you ever tried writing Haskell dynamically typed? You can do it, right? With the dynamic type. Data.dynamic. Whole programs with it. Don't type anything. Just use data.dynamic, right? It's an interesting experience because you have to like, you can't trust anything out of here. You got to pull all your data out, and you're constantly parsing it and reparsing it and validating it and stuff all the time, which is ultimately what you end up doing in like Python code bases and JavaScript code bases and stuff that don't have a lot of typing. You have a lot of checks everywhere, all over the place. Does this have this method, or does it look like a fox, or is it a lizard? You know, and that's like the difference. That's your empirical difference, right? There's kinds of bugs that happen in that translation from dynamic to like type, and those kinds of bugs aren't present when you have a language with a static type system that can be checked by the compiler. So that's my take on it. I don't know if that's a good take, but so it's not religious. It is technical, but I do agree that people treat it as religious, which is kind of silly, and I don't spend much time debating them. So anyway, all this is to say that I am constantly on the lookout for credible empirical evidence for the benefits of Haskell or languages like Haskell, especially regarding large projects. That's hard. There is not, as an industry, like, we're super bad at collecting empirical evidence about anything that makes us productive, right? Languages, practices, you name it. There's like hardly anything. There was a wicked ass blog post from a long while ago called What We Know We Don't Know. Hillel Wayne wrote it. Cool little talk, but this probably could be updated. There might be more now, but not many more. I'd be surprised if there was like more than 3 or 4. Yeah, there isn't a ton, right? And that was kind of when I started getting into formal methods around 2016 or so. That friend who got me into Haskell, the reason why I wanted to learn Haskell is because they took time out of their day to teach me how to like model stuff in TLA plus and like all the maths behind TLA plus and how to think in that way, and which I thought was very gracious of them. But yeah, I didn't want to see, and they were building stuff in Haskell, and I didn't want to seem stupid in front of them, so I had bad opinions of Haskell at the time. So I was like, okay, well, I'm going to learn enough Haskell so that I can at least keep up, you know. And then I was like, oh, this is actually pretty good, actually. And anyways, I couldn't believe that this tool existed and I had not known about it and nobody taught me about it, and it wasn't like more widely talked about. Because I had been working on distributed systems and large-scale companies for years without ever encountering it or using it at all, right? And all the kind of analysis and stuff was usually done informally. Documents with like graphs and diagrams and maybe the occasional formula, but nothing that was checked or verified, right? And that changed me a lot as a developer. I think it really changed my thinking about engineering, software engineering. That and another talk from Leslie Lamport, the creator of TLA Plus, software blueprints. I'm thinking above the code, both of those. Yeah, this was his talk. Who builds a skyscraper without drawing blueprints? Yeah, there you go. So yeah, some of these are like, there's just not a lot of empirical evidence. Like a large-scale study of programming languages and code quality in GitHub, faulty study apparently. He had a whole series of blog posts about this particular study. There was one that did mention Haskell that's kind of talked about a lot, which is because it's one of the rare instances where Haskell was actually like evaluated. Test-driven testing. Maybe it was that one. No, it was. Oh yeah, well there in negative Haskell. No, it was one of these papers. Anyways, it was like a military contract, and they were trying to evaluate programming languages, and there was some missile system they had to design. Everyone had to design, and so they had like a team in C++. They had a team in some other languages, and got to try to evaluate them. No, this isn't the one. But so few that I don't think you're going to find much there, Massive Squirrel. Like, there just isn't enough. Right? The reason to use Haskell is because you want to use Haskell. It's got something in it that appeals to you language-wise, that like makes programming nice for you, and helps you solve problems. Right? There are some technical things, like its runtime is pretty decently engineered. It's got a green thread implementation. We've been obviously learning a fair bit about it doing Bakamud. And it's got good libraries for doing that kind of stuff safely and just well architected. But above all, I would say it's because you like it. There's not enough. I don't think there's enough code bases in the world that are comparable. I could say like, here's Haskell and here's this. So unfortunately, that's just the way it is. Right, and Haskell has a very bad reputation in industry right now, I would say. If you follow any other streamers who just have been programming, like it's all Haskell, never. It's a white paper language. Lol Haskell. You know, and some people are not like big into Rust either for some similar reasons. It's got a lot of big brain ideas, so-called big brain, and I think the more popular zeitgeist right now is small languages that like Go. You know, anything more than that local maxima seems to turn people off for some reason. Not everybody, but some people. So your best bet is just blaze a new trail, you know? Don't follow the herd. Don't be concerned about what makes you look credible. Like me, I don't care. Some people might think I'm a dumb programmer and I don't know what I'm doing. Whatever. You know? You just keep plugging away. You be persistent. You be methodical. You just keep going, and you'll learn cool stuff. Yeah. I'll come do your motivational talks. I'll do motivational talks. I do motivational talks every now and again. There's a local programming meetup. I recommend if you don't know how to do talks and stuff, go find one and do a talk. You could probably talk about something for 5 minutes, I'm sure. 100%. But that's all I got for tonight, friends. That's all I got for 2025. So thanks again for a wonderful year, for following along with some of these projects that I've been working on. This is my website, agentultra.com. It's got links to Twitch, GitHub, everything else. You can follow me on the Fediverse, types.pl, at Agent Ultra. That's Mastodon. I'll paste that in there. That's got links to everything as well, including my YouTube channel where I back up the VODs for these streams. And maybe next year I'll start doing some videos and stuff, teachy type things. I don't know, but it's been great, and I'm appreciative for everybody. Chexor, you especially. Take care out there. May all your monads be free. Your types always check, and I hope you have a good holiday, and things will go better for you soon. Yeah. Start small. Take care. Go from there.